So we started with something simple, which is a balloon mission. It's a mission where we can sort of take more risks. This mission goes up above Antarctica and looks at exoplanet atmospheres, which is pretty amazing that you can do that from a balloon. But it had a simple problem. We needed to attach this tip tilt assembly to the back of this telescope. Seems simple, but the requirements were really tight. So the traditional way with, an engineer doing CAD and an engineering doing FEM and handing models back and forth, we couldn't meet the performance and manufacturing requirements for this bracket. But using our evolved structures technique, one engineer powered by AI in an hour can do over 100 iterations and come up with a design that's lighter, stiffer, stronger, and more manufacturable. And this technique was so powerful that we started scaling it across our missions. So these are a bunch of different parts for the Mars sample return mission. And in some cases, they enabled us to do things that we couldn't have done otherwise, reach performance goals that were not possible with just traditional designs. And then when we found out about Synera, we thought, well, hey, we have standard inputs, we have a process. Let's turn that into a workflow, basically turn it into code. So we had actually a couple brilliant interns who were able to get this working in about a week. And the power of this is when you've turned your process into code, you can just put it into other loops and you can use it on a vast variety of applications. So something that's sort of analogous to this tip tilt bracket you can do with this workflow, or you can do something like this. Same workflow, very different structure. And it's interesting for this particular piece, the inputs came from an AI agent. They actually didn't come from a human operator. So buoyed by that, we got into developing multi-agent systems. So we're going to talk about our text-to-telescope system and then show a brief demo of it in action. So you have a telescope supervisor agent that sort of has to know what its responsibility is, who's working for it, what tools they have, and it breaks the requirements down that you might enter in natural language so that the employees, digital employees beneath it can do their jobs. And then you have an optical design agent, and the tool that it has access to is a Python-based reinforcement learning tool that we custom built. And then it has access to an optomechanical design agent that encodes our standards for how we mount optics and does computational design and CAD. And then an FEA agent does the analysis. If you have active mirror elements, you may need a harnessing agent, and then a reporting agent to make sense of it to the human. And now to look at that really fast in action, you have the supervisor agent that you're connecting up to a large language model, and then you're giving it the information about what employees it has, what they're going to do, what the inputs and outputs to expect are, and then you're wiring it up to the other agents, so it's giving it a communication path, and then you're enabling the agents to communicate with each other, and also telling each of those agents what their responsibility is, what tools they have so they can do their job. Now you're going to see interacting with the system. In this case, we're using like an evaluation set from this bright mirror constellation and giving it, the inputs that you want that telescope to perform. And now it's taking those inputs and it's turning them to the standardized inputs that the agents are going to expect. Now it's going ahead and running the agentic workflow. And you can see very quickly it's come up with a design. And now what we're doing is looking at the communication between the agents, how they're talking to each other to make sure they sort of done something that makes sense. And here you can see what the CAD agent has done. It talks about what its inputs and outputs are. The FEA agent, you can see what the stress margins are. And then with the reporting agent, it makes it intelligible and easy to digest for the human operator. So you can see all the stresses, modes, and how the system performs. So to conclude, AI is radically changing the way hardware is developed. And there's a tremendous opportunity to both accelerate the speed of development and unlock game-changing performance improvements as AI finds solutions that humans might not have. And in the case of NASA, accelerate our exploration and understanding of the universe. Thanks.